Hello guys, welcome to my video. So today I'm going to be working out some polarization questions, also questions on Malus Law, as well as intensity. So this is part 2 of my 3-part video series. We'll be explaining polarization, intensity, and Malus Law. So this is the second part where I'll be explaining some of the questions and how you can answer them. So if you haven't watched out my video on Malus Law, I would highly recommend that you first watch that one out so that you can be able to have a deeper understanding and you can be able to follow as I'm working some of these questions out, because you have a much more deeper understanding of what Malus Law is and how that law can be applied. So I highly encourage that you watch that out. And please guys, comment, share, and like my video so that can be able to reach a wider audience and we can be able to help a lot of people. So moving on to May-June 2023, question paper 2. This is our first question for our Malus Law, and we're going to be explaining that one so that we can be able to answer these questions out. Okay, so we're given two polarizing filters that are arranged so that their planes are parallel and vertical. So the first filter has its transmission axis. So this shouldn't be a new word. It basically means that what is the axis that a certain polarizer is actually positioned. So basically we think of this, I would like to think of this as my polarizer, and I'd like to think of this as my analyzer. So this is my polarizer and this is my analyzer. So I like to think of them as two separate things. My analyzer, okay, and this is my polarizer, right? So we've been told that angle alpha is greater than 35 and not less than 90 degrees, right? So a beam of vertically polarized light has intensity of 8.5 watts per meter and is incident on the first filter, and we've been asked to show that the intensity of light transmitted by the first filter is 5.7, right? So what should come to mind is the equation for intensity itself. So what equation do we know, right, that can be able to give us the intensity itself, right? And what equation can we apply? Because we're given an angle theta, remember. And once we've been given an angle theta, we can then be able to apply Malus Law, right? What does Malus Law state? It states that the intensity of the transmitted light, right, so the intensity that comes out here, is equivalent to the product of the initial intensity cos squared of theta, right? And remember, it's important to know, what is this angle theta? Always ask yourself that. So you've been given a beam of vertically polarized light. So this light is coming in this angle, right? So it's vertically polarized like that. So it's basically coming in vertically polarized. And as it reaches here, it's going to be affected by this angle. So the transmission axis before was actually like that, right? But now it's actually like that. So this polarizer is rotated at a certain angle. So we have two filters. It doesn't really matter. You can have many filters that are there, right? But what's important is to understand the principle. This angle is coming in, this light is coming in vertically, but this angle is positioned in this angle at 35 degrees. So your angle of theta is this angle, guys, from this axis to that axis. So it's 35. So the intensity that you get out would be, what is your initial intensity? It's 8.5 cos of 35. And how do you punch squared of that? You go to your calculator and you say 8.5 cos 35. You put all of that in brackets and you square that, okay? So that's how you punch cos squared of theta. So your intensity would therefore be equivalent to 5.703586, something like that, and that gives you an intensity of 5.7, right? So it's very important for you to understand what these formulas actually mean and what these formulas can be applied, because this was basically an application of Malus Law, right? We knew that the intensity that we get out is related to the intensity that is before by the angle that is theta, and we knew that the angle theta is 35, so we can find that angle, and we also knew the intensity of the incident light, right? Moving on to question part 2, we'll be given the intensity of light transmitted by the second filter to be 5.2, right? So it's light that is now coming out of this one, right, at an angle of 5.2, at intensity of 5.2, and we've been asked to find the angle alpha, right? So we've been given the intensity already. So let's go. We know that I2, okay, is equivalent to I naught cos squared of theta, right? What is our value of I2? It's actually 5.2. What is our value of I naught? Is actually 5.7. So I naught is this incident light, which we have calculated to be 5.7. So that's cos squared of theta. So 5.2 divided by 5.7 is actually equal to cos squared theta, Therefore, the square root of 5.2 divided by 5.7 is actually cos of theta. Hence, theta is actually a cos. The square root of 5.2 divided by 5.7, and that gives you a value of theta to be 17.28 degrees. But is theta alpha? Theta is not alpha, guys. So if we go back to our question, right? Theta is the angle between the transmission axis of light that comes in and the transmission axis that light is facing out. But angle alpha is greater than 35 degrees, meaning that the light that is coming out is maybe coming out at this particular angle, right? So it's probably coming out at this particular angle, meaning that the transmission axis of this one is actually like that, right? So basically this is your transmission axis, but this initial one is at 35 degrees, and 35 is not the same as alpha, meaning that is something like that, right? So the value of theta that we're actually calculating is something like that, right? So basically this is our value of theta that we've calculated, but alpha includes all of this part, and this part is due to the 35 degrees that is over there. So you have to understand really what is your value of theta. The angle between the transmission axis, even if it's at 35 degrees, take that axis and put it over there. And you figure out that if it's at another angle, which is at alpha, the distance, the angle between those two lines is actually your value of theta. And once you have that value of theta, you now know that alpha is actually theta plus 35, right? So your value of alpha is actually 17.28 plus 35. That gives you a value of 52 degrees, right? So your answer is 52. Moving on to the next question. So this is for February-March 2022. Okay, so let's begin. We'll be given a beam of vertically polarized monochromatic light, right? So vertically polarized, so it's already coming in vertically polarized. So you must be able to understand what these questions actually mean. So your light is already coming in vertically polarized, right? So previously, before, it's vertically polarized, and we have a polarizing filter. So this is the transmission axis of that filter, and this is the value of angle of theta. So it has already been filtered. So what is your value of theta? It's actually this transmission axis and that transmission axis, and this is your value of theta. Always draw those two things, right? And we've been asked to consider the ratio of this so that we can determine the amplitude of the transmitted light and the amplitude of the incident light. Remember our equation, the equation that I told you that relates intensity and amplitude, right? We know that intensity is directly proportional to amplitude squared. So this is first marking point. You need to know that the intensity is actually directed to the amplitude squared, meaning that the intensity that you get out, so intensity of transmitted wave will be equal to K times the amplitude of the transmitted wave squared, right? But the same also applies to the intensity of the incident light. So intensity of incident light will be equal to K, the amplitude of incident light squared. But the question wants us to find the ratio of the amplitude of transmitted light over the ratio of the amplitude of the incident light. So we can express this as one ratio. So that intensity over that intensity will be equal to K, the amplitude of the transmitted light squared, over K, the amplitude of the incident light squared. So that cancels out. But we know that the intensity that we get out is actually I naught, right? So the intensity that we get out is actually I naught, okay, cos squared of theta, right? Divided by I naught is actually equivalent to AT squared over AI squared, right? So the value that we get out, so this is the same, so this basically cancels out. So AT over AI, right? So AT over the value of AI, sorry. So AT, okay, so AT over AI is basically the square root of cos squared theta, right? But we know that theta is actually 20 degrees. So if we look here, the value of theta is actually 20 degrees. So it becomes the square root. So A naught over I naught is actually the square root of cos 20 squared, which is basically 0.93969. So your ratio becomes 0.94. So the first marking point is, do you know that intensity is directly proportional to amplitude squared? So I want to stress this out. This is golden, okay? You need to state that formula, and you have to apply these laws. You create your ratio, but you know that this is actually equivalent to that, and you substitute, this cancel out, that cancel out, you get this important relationship. You already know your value of theta. You go back here, your value of theta is actually 20 degrees, and that gives you your value of intensity. Very important. Moving on to the last question. then the filter is now rotated about the direction of the light beam from its starting position shown, right? The direction of rotation is such that the angle of the transmission axis to the vertical increases, right? So it's being rotated, so it's basically like this. So this was basically our angle theta. So it's now rotated in this direction so that the angle of theta is actually increased, right? So very important. And we've been asked to calculate the minimum angle through which it must be rotated so that the intensity returns to the value that it had before. So how does intensity return to the value that it had before? If you recall how we were working these things out, we said that intensity is the same whenever the angle is the same as the angle of the polarized light, right? So for example, as I said that if theta is 0, it basically means that there is no angle between the incident light and there is no angle between the transmitted light. And if that angle is 0, it means that all the light passes through. So basically we want an angle to the vertical such that it is 140 degrees, right? So how do you calculate that? Well, we already know that it's already 20 degrees to the horizontal in that direction. Means that if we were to rotate this, so if we rotate this in this direction, right, such that it's vertical, such that this is vertical, this moves through 70 degrees so that it reaches 90 degrees. Okay, do you agree? So it has to move 70 degrees so that it's at 90, so that the light that comes out here is actually at 90 degrees, right? We can continue doing this. So we can rotate it again so that this angle to the horizontal is now, so we can continue to rotate this so that this angle is now, so if it moves here, so this was 90 degrees, right? So we can rotate it another 70 degrees to that direction, right? And if we rotate this in that direction, you'd actually realize if we were to extrapolate this, okay, this value of theta is actually 20 degrees. It's just in an opposite direction, but the angle theta, okay, so let me draw that so that it's clearly visible. So the angle theta is still 20 degrees, right? So if we were to draw our transmission axis from that angle, right, this angle is just still 20 degrees, but we have moved it 70 degrees here. We've also moved it 70 degrees here, but it still returns back to 20 degrees. That's how angles work. There's more than one angle for giving you the value that you want to get out, right? So the angle that you have to move through has to be 70 plus 70 for you to go back to the same angle. So remember, the rule that happens is for you to return back to the value that you had. The angle between the transmitted light and the incident light has to be 0. Right? It has to be the same. So for it to go back to 20 degrees, I can rotate it. The minimum that I can go is 140 degrees, and that becomes my final answer. So the answer is 140 degrees. Moving on to the last question for this series. So it's for October-November 2022, question paper 2-3. A longitudinal sound wave is traveling through a solid, and the initial intensity of the wave has been given. It's I0. The frequency remains constant, and the amplitude falls to half of its original value. So remember, guys, this is the same one that I did in my Malus Law video. I would highly recommend that you watch that. But basically, it's the same principle, right? So we want to find the final intensity. So you go back, you say that you know that I, okay, is equivalent to Ka squared, right? This is your initial intensity, I0, which is equivalent to Ka squared, right? So if intensity falls half, it means that the amplitude is now half of A, right? It's now a different amplitude altogether, right? So if we were to go to our values here, we know that the value of I2 that we get out will be K half of A. So substitute that, half of A squared. So I2 will be equivalent to Ka squared multiplied by half. But Ka squared, guys, is actually I0, right? Because K squared, okay, sorry, so K squared, so this half has to be squared, so half squared is actually 1/4, okay? So this Ka squared is actually the same as that, meaning that I2 is actually 1/4 of I0. So what this means is that by reducing the wave to half, we're actually cutting down the intensity by a quarter, right? So basically, the intensity that we get out will now be 0.25 I0, so I2 will be equivalent to 0.25 I0. So I would highly recommend that you just write your ratios in terms of their fractions, right? So very important. So remember the following principles. Write the equation that you know down, right? Go back to the fundamental principles. What equation do you know? You know that this equation is true. You also know that that equation is also true. You know that if it's reduced to 1/2, you can put that half here. If you square that 1/2, you get 1/4, and that is equivalent to that value. You substitute that, you get your value of I2. So this is the end of series 2. So I've been answering a few questions so that you can be able to understand how the law works. And in the last series, part 3 that I'm going to be uploading, I'm going to be finishing some of these questions off so that you can have a deeper understanding of Malus Law. Thank you for watching. I would highly recommend that you watch some of my videos. So this is my paper for May-June, okay, May-June 2020, question paper 2 for physics. And this is my video for Malus Law, okay, and this is my video for the May-June 2023 question paper 1-1 for physics. Okay, so thank you for watching. See you in the next one.